I'll give you a little slide real quick. Yeah, so about me entering my final year of studying computer science at the college, interested in a lot of topics. And I'm also looking for a 2025 summer internship. So in case anybody likes my work enough, feel free to pass it on. Check out my LinkedIn. Thanks. All right. Okay, so to start,
We can't see the slides though.
Oh, you can't see the slides. Are you watching my stream? So in Discord.
Yes. Yes.
here I can load up Discord.
So now I've changed to Zoom. Can you see Taylor's slides that says eduRANGE or not?
No, because I guess when you screen share, you only share Discord. That's why we can only see Discord.
Thanks for saying that. I probably clicked the wrong application. Try again, please.
Yeah.
Can you see it now?
Thank you for saying something. Yeah, perfect.
Thank you.
Awesome. Okay, so so for the actual like application, so this is for eduRANGE, which as was mentioned, is I've been working with Richard as my advisor for this. eduRANGE has been a project for over a decade, I believe, and it's you know, a National Science Foundation funded project. It's both a collection of like interactive collaborative cybersecurity exercises and a framework for creating those exercises. So essentially, students participate in cybersecurity scenarios, and there's an instructor who kind of, you know, starts the classroom, manages the classroom, and it's been evolving. It's been evolving over the years, and it's become a really intricate framework. So with eduRANGE, for the summer, I was tasked mostly with helping apply machine learning to solve a problem with eduRANGE, or a problem that instructors face on eduRANGE. And mainly that's identifying and assisting students who are struggling. And so these are students that are like demonstrating an ongoing difficulty with completing a cybersecurity exercise. So as students participate throughout the exercise, you know, they may get stuck. Mostly they're using an SSH shell and interacting with the exercises in that way. They also have a chat system that they can communicate with the instructor with. And then they're also answering questions. So we have like web forms to answer questions. So as they're going through a scenario, you know, there's different themes, and they essentially work through the scenario using their shell and answering questions. And yeah, and so yeah, a big problem was identifying who's struggling and then assisting them, identifying and assisting them. So my objective was to figure out ways that maybe machine learning could bring some creative solutions that we hadn't thought about when it comes to identifying and assisting these students. So essentially what I developed was a dashboard for instructors. So these are the people who are hosting the actual application on a server, a local server that students connect to. So the instructor has the ability to see different groups. So students are grouped into like, well, just groups. And these users then complete scenarios. And so for this dashboard, there was a couple key things I was thinking about. So for identifying a student, the first thing that came to mind was, let's see exactly what the student's doing right now or recently. And so the first feature I developed was actually being able to retrieve the student logs and display those to the instructors. So you'll see here we have a group and we have a user. So essentially they can choose a group that the students are participating in and then select a specific user. When this is done, it'll display the three categories of interaction that they have on the platform, which is the bash logs, their chat logs, and their answer history. And essentially the instructor is able to see these pieces of information. And while it's not as complex as it eventually will hopefully develop into, right now it's kind of an easy way for the instructor to see. This is also done on a different section of the platform, but I wanted to integrate it directly into this dashboard. So yeah, so this first section, you'll see student logs as a drop-down menu. This can be expanded or decreased. So yeah, you'll see student logs are received asynchronously from the database, and then I cache them in Redis so they can be more easily retrieved, essentially just quicker retrieval, also for generation, storing them. So essentially you don't have to, you know, make another pull to the database. So for actual generation, when generating, there's different settings. So I've essentially created some presets for prompting the model. So essentially I have two main presets for it, and that is to prioritize speed or to prioritize quality. Essentially, if you're prioritizing quality, there's more context when prompting the small language model. When you're prioritizing speed, it's all about speed. There's less context, but generally has decent performance. And then, yeah, once you press generate hint, the hint will appear there after generating, and I'll show you the actual diagram for what this looks like. And actually, let me show you the diagram first. So essentially, eduRANGE already had a development stack that I integrated with. And so that is with React for the front end components, Flask for the back end, and then some other back end utilities. So in particular, Celery for asynchronous tasks, for calling asynchronous tasks, Redis for caching, and then we were using a PostgreSQL database. So when integrating the main usage, the main utility with this dashboard, and I'll go back real quick. As I said, it's generating hints. And so in order to achieve this task of generating hints, we're actually using a cutting edge small language model. Now, opposed to a large language model, a small language model is far less parameters and essentially has a few main benefits. With its smaller size, it also is as a file, it's a smaller file. And so it allows, obviously, the benefits of having a smaller file. But in particular, with running these complex models, typically you need a dedicated graphics card to run such models. Inference is usually just a lot of resources. And even to do that, it can be inefficient. So why we're using a small language model as opposed to a large language model is that small language models their main feature is they're many times less parameters, allowing for smaller files and less compute. So obviously less parameters, less weights to calculate. They can be run entirely local with pretty much the backbone of this application, which is the inference library Llama CPP, and specifically the wrappers Llama CPP Python. And some of them are open source. So in particular, the small language model I'm using is Phi3, 4K mini instruct, which is from Microsoft Research. It was recently released earlier this year, and it's a very cutting edge model. It's been having a pretty substantial gains in performance to the actual parameter size. So the typical like resources it takes to compute. And so just looking at small language models, some of the pros, in particular, I've been able to achieve with Llama CPP Python and a Phi3, a GGUF, which is a typical file for kind of storing all of the weights. You can think of it as like the model file itself. I've been able to run it on a consumer grade CPU. So inference it can be done entirely on just a CPU. A dedicated graphics card is not necessarily needed. It does exponentially increase speed, but I've been getting pretty reasonable results on just a CPU. And this is also with quantization and such. And additionally, by having it be run entirely local, having such a smaller model, something more reasonable to run on your own hardware instead of having to interact with a third-party API, it's allowed local computation. So you don't need to reach out to ChatGPT, you don't need to reach out to any third party. And, it comes with that, obviously interacting with a third-party API, it can come with data risks, it can come with privacy concerns and such. So this is an added benefit of computing it locally and having those results on your local hardware. Some of the cons of it is that, such models, like they don't perform obviously the same as a large language model, though that difference is shrinking I would say, every month there's developments and such. Phi3 was a big step from Phi2. And then also, I mean, modest hardware is still required. My tests here were with an i7-13700K Intel processor, which is still, it's consumer hardware, but it's still a pretty high-end CPU. And yeah, even though I think it's still incredible what this model's been able to achieve. And so let's go back to this diagram. So specifically, so building off of the stack for eduRANGE, we have a front end components with React. We're using Flask as a server router. for our backend. And then we're asynchronously dispatching celery tasks. And specifically, there's three main API calls that you can make here. So we have get logs, which is actually retrieve a student's logs. So this is like with their user ID that we identify them with. So you can retrieve the student logs. And this goes back to the feature for displaying these logs for helping to identify students. You can query the SLM. So I created a full abstraction for this specific task of querying phi3. And so essentially what happens is you pass the object through. There's certain specific, I've created some generation specifiers, some Redis specifiers, and essentially from the front end, you can make a request that goes from React to Flask, dispatches an asynchronous celery task, and then computes inference locally, entirely locally using Llama CPP Python, and then Microsoft's Phi3 small language model. And additionally, I use Redis to load, store, and delete student logs. And specifically, I don't know if this has been done or used widely, but I kind of came up with a technique for I just store the language model in Redis, and it actually sped up inference for me because I wasn't having to re-grab the language model every time, and wasn't having to store it in a database. So just keeping it in the Redis cache upon initialization of the application itself sped things up for me. And then, yeah, for the logs are actually pulling from a PostgreSQL database.
Taylor, is it okay to take questions now or yes?
Yeah, sure. I can take a question.
Yeah, so on Zoom, Pedram is asking, is the model stored locally? It sounds like you just said that you put the whole model in Redis. Is that right?
Yeah, and you could download the model file if you really want to. Essentially, I haven't been keeping it in there because it's just, yeah, it's easier right now with distributing it as a web application to just pull it from Hugging Face transformers currently.
And is it possible to run this on the Raspberry Pi?
Taylor, I'm laughing because Taylor has a pretty powerful GPU machine, which is much more powerful than the Raspberry Pi.
Yeah, but CPU, I actually don't know if this could run on a Raspberry Pi.
The reason I'm asking Raspberry Pi because of the different architect, like an ARM architect. And I'm not talking about the performance, but I want to understand, this is compatible with ARM or just the x86?
Question, yeah.
I would have to. I've been doing it on x86, but I would have to check the documentation to see if it works on ARM processing, on ARM architecture. Yeah.
And the GPU is required, right, for running this?
Nope, GPU is not required. You can run local inference entirely on a CPU.
What's a minimum RAM for this?
What is that?
What is the minimum RAM to run this locally?
Oh, minimum RAM. So for my testing, essentially, you really just need enough RAM to store the model into memory. Essentially, these libraries, they store the entire model in memory in order to speed up inference. Theoretically, you don't have to, but my understanding through the documentation is that this library in particular, I'm not sure how you would disable it. For my system, for my testing, I was testing on 8 GB of memory. But for example, this model itself is 2.2 GB. So I mean, maybe there's some overhead that you should account for. Obviously, in maxing out your system memory, but I mean, I could imagine 4 GB of memory being okay. And honestly, that's something I'll probably test.
Okay, another. Sorry, I'm asking lots of questions, but so is it correct to say that if you are dealing with a small large language model, you have to mature your prompt more than the large language model we have? So it means we have to put more load on the prompt rather than on the LLM. So it's like a thin client and thick client, if you remember these kind of terms years ago. So we put more information on the prompt to be able to generate more meaningful information on the small large language. Is it correct to say that? If that makes sense.
I'm not currently aware of the distinction of why a prompt would need to be more specific for a small language model. Is that what you've heard?
Yes.
Oh, okay. Yeah, I've gotten pretty decent results from having a very concise system prompt and user prompt. And in particular, I've spent a lot of time actually working through and testing, and I use a specific framework for prompting called Clear. And I've tested with a variety of different prompts. Some were much longer and some were much shorter, but I've actually settled on a fairly short prompt of about 2 sentences and kept it
Oh,
concise. And most of the information being used is just contextual information, so like student logs
got it.
and additional like relevance to these cybersecurity scenarios. Yeah.
So this work is only purely done on the Phi 3. You didn't use the other models. This was only this model.
Yeah, I was pretty much just optimizing and reading documentation. And so I developed, yeah, primarily just for Phi 3.
All right. Okay. Is it possible to merge the different large language models, small large language model, to find what is the most efficient? I mean, this work that makes sense if you are, for example, working with the Mistral, working with the Phi or other things, and to find out which parameter is the best to, for example, for your application. Does it make sense to work on the several different small large language model to create your own large language model, or is just a wasting time? I think in this kind of mindset.
Well, I guess currently, the main reason why I was drawn to using Phi 3 in particular was it was open source, released by Microsoft, and it appears Microsoft has taken a big step in sort of open sourcing machine learning
Mhm.
work to kind of like, well, inspire an open source community to kind of, push that boundary. In particular, I didn't test any other models really because a recent paper, which I reference in here about Phi 3 is really, from my research, is kind of the undisputed king right now of small language models, in particular, those that are open source. So I mostly was looking at open source small
Yeah,
language models. I would clarify, I don't know if it's the king of all small language models, but I think it's the leader for open source, which was a
have,
key thing for me because eduRANGE is a nonprofit and or as an academic project, and I wanted to maintain open source as a
got
priority.
it. Okay. Have you tried the other models, or you just started with this small large language model 5?
No, I've only really tried Phi 3 so far.
So the reason because of the least parameters and open source. That's why you started this to work on this one, right? These are the
Yeah,
two
those
main reasons.
two, and also just good performance. I mean, just generally good performance, for its size. Yeah, those three
Okay.
are the three things
And
that.
at the moment, this is the least number of the parameters as a small large language model in the market, or is there another things like that?
The smallest number of parameters, is it?
Yeah, I think specifically, it's at 3.8 billion parameters.
Okay,
Uh,
in the website it's mentioned 2.7, so I don't know why exactly which one is the correct one.
oh, I might have written down the wrong number. It could be for the mini. I'm using the mini, so I might have actually typed down the small for parameters. But yeah.
Yeah, Bedroom does raise a good question, I think, about the prompt. So are you passing in the student logs with the prompt? Can that be considered part of the prompt? Because then the prompt is quite big. It is quite heavy, as he was asking about.
So
Yeah.
yeah, here, let me address the prompts. So specifically, let me actually go back and show you this.
So
So
let me clarify my question more. So for example, if we are using the agent, like a LangChain agent. So in our agent, we try to tune our prompt for the different data set. It means for different application. So for the different application, we try to customize the prompt. Do we have to do something like that for when we are dealing with a small large language model with more text in the prompt, or it doesn't matter?
I haven't identified a need for having more additional text than I would if I'm just like asking ChatGPT. I haven't. I think it kind of comes down to Um, I mean, this small language model, it's being used for a very specific task. And so I'm having like one very specific result I'm looking for in generating this. So I haven't found any, I haven't tested a prompt and felt like it didn't quite get the information I need and I need to make it a lot longer. I felt like it was pretty concise. I was able to achieve results with pretty concise prompts.
So I would like to share my experience. So I made a small code in the Colab, and when I added more text in my prompt, and when I ask my question and make my question longer, I have a better result. So I'm just wondering, this technique can be helpful for when we are dealing with the small large language model. If I have the larger prompt and larger and more meaningful, more meta keys include in our question. Um, I'm trying to understand what would be the best technique to have the better result.
Yeah, I mean, with more information, the more information you provide in the prompt, assuming you don't like break the input context length, which example 5.3 has about 4,000 tokens. For max input context length, that it can take as in context is about 4,000. There's two different models. There's one with 128,000 context length, and then one for 4,000 input context length.
Well,
This is the maximum is 4,000 tokens.
For the mini, which is this one this small, the 2.2 gigabyte model, yeah, it's about 4,000. It's 4,096.
OpenAI doesn't let you have more than 3,000, 3,700.
Yeah, so I guess this one exceeds that in having that.
And it's very interesting. I would like to share something. Maybe it's interested for you. So, with you guys. So when I decrease the number of the tokens to from 3,700 as a maximum to 1,000, I still have a very interesting result. So I'm trying to find out what is the best and the most important parameters: prompt, number of tokens, the quality of questions, the agent, all of this. I would like to find out, because I think it's very important to find out what is the most efficient system you can create it, you can develop it for your large language model in the future, if that makes sense.
yeah, these are good questions. I think we're all ongoing trying to figure it out as we go along. So yeah, in the future there could be a venue for sharing. I think this is valuable empirical knowledge, you know, like the tuning of the prompt and the number of parameters and token length, the context length. Yeah. Let's let Taylor continue for a little bit more if that's okay. And
Sure. Sorry.
yeah, more questions later on. So.
Yeah, so for like with talking about length for the system prompts, so specifically here, as I kind of demonstrated, I have a prioritize speed or prioritize quality option. So if the user selects prioritize speed, then essentially the actual system prompt will be slightly changed, and the user prompt essentially are the same for both settings, but the difference is that this scenario summary. So essentially each cybersecurity exercise, I mean, it's a scenario, so it kind of has like, you know, certain parts to it, certain sections, there's certain things that we want students to learn. So for optimizing speed, I actually just try to rely on what 5.3's like trained data is. Like, for example, like syntactic problems or kind of like, I guess, surface level problems. The scenario summary doesn't really add a lot of important context to it. If you're just running into like technical errors or you're mistyping something or you're just not understanding a definition, 5.3's training data, as I've seen it and as I've read in the paper, it provides a good expertise, a good background on a lot of these cybersecurity topics, on a lot of these just general programming topics. And I've been impressed because a lot of times, I mean, if you don't need all that additional context, you can speed up generation by essentially not adding in a scenario summary. But if an instructor feels, looking at their logs, at the students' logs, that this might in particular might be something more about like the narrative or, you know, the actual like scenario itself, like if there's like a secret file or something as such, adding in the scenario summary can actually help provide additional context to the model. And so the speed comes because the actual prompt is shorter, but in exchange sort of for quality, right? Like there could be more information that could be provided to very clarify the prompt. So here's some examples I've had for generation. So this example particular, and I did want to be a little bit more focused here. So this is an example where I just imagine, which I did, I kind of engineered this, but these are real generated hints that were generated from this. A frustrated student is a kind of a common thing. So, you know, they're spamming man SSH, trying to figure out what this does. This is the beginning of one of the scenarios. And then, you know, maybe in the chat, they asked the instructor, you know, I typed it in but there's too much stuff on my screen. I'm confused because when you type in the man page, it can appear a lot of stuff. And so in particular, these are some hints I got. So start by focusing on a specific, this first one is with the full scenario context enabled. So it's looking at the whole scenario summary. And essentially another thing is that with even, this is kind of something where you don't really need the whole summary. But yeah, you can see start by focusing on a specific section from the SSH man page to understand SSH basics before attempting more complex tasks. Use less or more commands to navigate through the man pages and find relevant sections related to your current task. So this is with additional context. And then, version 2 without additional context, check for specific sections in the man page related to SSH usage and authentication. Focus on understanding how to securely connect to an SSH client, which is one of the next steps in the scenario. So for version 1 with the additional context was 30 seconds for generation. This is on 8 gigabytes of memory, 8 core CPU. And I have some more specs, temperature and such, 30 seconds. And the second one without the additional scenario context is 14 seconds. So, the main usage of this is that the instructor sees a student's logs. They identify that the student might be struggling with something, or they see like repetition in their commands for this example, right? If they just keep typing it in, they might be frustrated. They could see through the chat or they could see their answers. And, perhaps they think, well, this is something more on like specific to the scenario. This requires additional contextual information for them to solve that. Then they might add in the additional scenario context. And if not, they might just go for the quicker speed option. Yeah, and then so for future work, so that was just one example there. I'm working to we record the logs for students in these exercises and store them as CSVs. So I'm actually planning to like go back and essentially create a lot of pre-generated hints to kind of get more examples and more results. And in particular, I'm doing a classroom test next Wednesday where we actually be testing the system in a classroom. And I plan to do more of those and get more results on that to further kind of like tune the system to see like, are these prompts working? Is it generating hints in like an expected manner? And yeah, and then some other features I'm thinking about implementing is like some more traditional machine learning tools. Like, so in particular, like more tools for identifying students, like, seeing their logs and can we, make out clear depictions or clear identifiers for which student is struggling. And yeah, and then also the other benefit is that since I'm generating these hints, might as well store them. And I think through some curation, these hints could be actually matched to a student through a recommendation system. So that's another thing I've been looking at through machine learning. While the real-time application of this, like generating hints in real time, might not quite be there, especially because of the generation time. I mean, I think it's reasonable. I personally think it's reasonable, but I can see why others would disagree. I think creating a database of pre-generated hints and learning to kind of go through and curate them and maybe apply them to a recommendation system so we can identify students that might be the best suited for those hints. And that might be a quicker, better real-time application. And yeah, and then I'm planning to present these results, hopefully culminating in a research paper on the topic. And yeah, those are my references.
Very nice. Thank you. Thank you so much. It was great.
Round of applause for Taylor. It's all on mute. You can clap emoji. Yeah, thanks for coming, Richard. I saw that he had to leave on chat. And yeah, I think we have time for a few questions.
Taylor, you were able to just run the file and then disconnect from Wi-Fi or anything from internet, and then you get the result. You were totally off the grid and then get the result.
Yeah, I mean, so I could unplug my Ethernet cord. This can be computed entirely locally. Yeah.
All right. Very interesting.
Any other questions? Yeah, go ahead.
Just a quick question, sorry. And what was the reason you're using the Postgres here? if you have is that possible just using the one vector database as a MongoDB instead of two different databases like a Redis and database, like a Postgres as a rational database?
Yeah, I mean, so this was just kind of the stack I inherited. So as I was kind of, working already in an environment in a project. And so this was the database that was there. And so essentially I designed my systems, kind of architected them out, and then implemented them into the stack. And it made some improvements too with Redis because there wasn't quite a framework there for using it, and I implemented a lot of utilities for that. And so it sped it up a lot. So Redis is more of just a cache. It's kind of a cache database for like
Yeah.
that are gonna I'll be needing to retrieve.
The reason I'm saying because if you vectorize it, it's going to be much faster and more efficient your system. So the Redis doesn't have this feature, and Mongo or DocumentDB has the vectorized feature. Maybe I don't know. This is my thought, and maybe I'm wrong. But I think if you're working on the deck vectorized, it's going to be more faster.
Faster than the Postgres. Sorry, what was
Yeah,
which
yeah.
technology?
The reason because you are going to vectorize your model, and every time you just call the vector instead of the model, so it's going to be much faster. This kind of transaction. Every time you're pulling out the information or any information or knowledge you're extracting, is going to be vectorized and then stored as a one vector inside of your database. And it's much easier if you're dealing with an unstructured data, if that makes sense.
Yeah, primarily, and this is kind of the actual speed. Essentially, the model itself doesn't like the actual inference, like my application for actual like inferencing with it. It
Mhm.
doesn't actually rely really on Postgres speed because it's essentially the data is already cached in Redis. So essentially, and I'll show you this. So essentially, as they select a group and then select a student, that calls the asynchronous celery task that retrieves the logs from the database.
Mhm.
So essentially, the upfront cost is you retrieve the logs before it, and then generation itself is kind of independent of that. You're essentially just pulling from the Redis cache and using that information for generation and then
Right.
sending it back to the API. Yeah. So
Right.
it's actually it's not dependent on Postgres speed for like reads and such.
Got it. Yes. Okay. Yeah. Thank you. That's a great.
But it could be interchangeable. I mean, you could really put any database there. It's abstracted. So
Understood.
Bullock is still on the call. I know you have an interesting graph databases, and I learned about vector databases from this work. And so, sometimes there's a nearest neighbor search. You can represent points in the feature space as vectors, like n-dimensional, like very high dimensional, and then your queries are finding sort of the nearest neighbor, and it's probably internally using a KD tree or whatever well, actually, I don't know what it's using, but there are databases called vector databases, and I didn't realize that before. And it's just like graph databases are specialized for one type of representation. Yeah, and other specialized databases. So
Yeah. Yeah. All right.
I've not worked with it, but Neo4j also does have vector embeddings now as one of the data types it stores. I've not tested it out at all, but that's there.
Oh, that's worth looking into. I wonder how that interacts with the graph part.
Yeah, there's quite a few videos that I need to watch to get caught up on. I've been working with OrbitsDB, which is a Web3 based on ceramics network. And that's where most of my learning has been for the last week and a half, but it's definitely on my list of things to look into.
Cool. Yeah, I'll go through and compile a list of notes, like what's the word, like liner notes, like in an interview or something. Yeah, I'll post them in the YouTube link whenever I upload this.
Yeah, there's a lot going on with Neo4j for RAGs, which is retrieval augmented
generation.
I guess generation. That's it.
Yeah.
To where you use an external database to keep from hallucinating as much.
Yeah, that's something actually I was interested in exploring more. Retrieval augmented generation, like for retrieving relevant scenario information and such. But I think the scenarios they're kind of compact and they're relatively short, these summaries, and so I really didn't find much of a need to go through and vectorize everything and implement that. But I don't see any. I think it'll only speed it up. So that's a further improvement that could be made.
By the way, this is a very interesting book about RAG, and if you're interested, I can send the name of this book, Generation Error with the LangChain. So it's talk about the recent technology in AI in the LangChain. I will put it here, the name of this book.
Yeah, please do. It says generative AI with LangChain. Looks like an O'Reilly book.
Yeah.
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 That's cool.
Very good book.
I'll look it up.
Yeah, you didn't use LangChain in your tech stack, but it sounds like you know like how it works.
Yeah, I looked into it. There's a lot of technology that there's so many different ones. Yeah, I really didn't explore it too much. Llama, CPP, Python caught my eye in particular. But there are additional ones. I'm interested. There's one in particular. There's a talk recently released called Llama File, which can offer up to 300% faster inference on the CPU alone. I think their primary focus has been on speeding up inference on the CPU. And in particular, they've made some improvements with inference, and yeah, the results seem very promising from the talk I saw. But the main thing, I tried to actually implement some of that, but I was running into issues. In particular, it seems like in order to run inference with Llama file, it creates like an executable, but it seems like they use the AVX instruction set. They add that, or it's a requirement to use the AVX instruction set with it, which is like an additional kind of thing your CPU requires. And in particular, I was virtualizing through VirtualBox to like reduce my actual like hardware, my actual hardware specification, so I could like kind of emulate a lower like CPU hardware. And I was running into issues, and apparently AVX cannot be virtualized through like VirtualBox, for example. So I've been looking at Llama file in the future, but my concern is that if I kind of want it to be as accessible as possible. So maybe that's like a feature that if you have an AVX CPU, like it can kind of opt in to use it, but generally supporting like not having to have AVX, because I know I believe that's mostly for higher end CPUs.
Yeah, it sounds like it might be an Intel only instruction set extension. Well, I don't know for sure. Maybe ARM has something similar.
Yeah, maybe. I'm not, I just, yeah, I saw it was an additional instruction set. So I don't know the particular if it's exclusive just to x86 or if it's also ARM or yeah, so I wasn't quite sure yet. But that's something I'm probably gonna look into more. Always looking for the next, speed gain, the next thing to make it faster.
Yeah, is speed a bottleneck for you right now? I mean, you mentioned these two sample hints that were like 14 seconds and 30 seconds, I think. I guess that, that does affect the user experience.
Yeah, I think sort of almost think of hint generation almost as like an asynchronous task for the instructor themselves. Currently, like you generate a hint, and then my hope, I haven't fully integrated so that they can like move to other tasks and use the website for other purposes. Currently, you have to stay on the actual dashboard, so you can't do another thing. But I've sort of thought of it that like in the role of an instructor, right, an educator, someone in the classroom tangibly or virtually, typically like in between actually like doing a task on our application, they're also going to be doing other things, right? Like they might be talking to a student, they might be doing other things. And so like having this be almost like it is literally an asynchronous task, but to kind of picture it as that, like they can do this and then go do another thing while the hint's generating and then come back, check, send it. Yeah, so it's been I think though with like 5.4 or whatever it comes next, I'm constantly like looking at other open source models, and if I can find a smaller model, faster model, any of these things, I've pretty much just built the infrastructure to essentially you can put in any GGUF file, pull from any specific GGUF you're looking at on Hugging Face and use this infrastructure for it.
Yeah, I think this will come up a lot for any kind of AI product. Because it will be slow at first. And, you mentioned letting the user navigate away, maybe having like a progress gauge bar so they know when the task is ready, like queuing it up, or having it be on the server side, like it being an instructor thing. And you mentioned that eduRANGE can be self-hosted. So it can be like an instructor spins up an instance just for the class and then tears it down, as opposed to the cloud-hosted edurange.org. Which I think is the public version that we can all try. And it looks like right now you've been testing it on your own computer in like you're the instructor. Is that right?
Yeah, pretty much. And yeah, for eduRANGE, everybody just essentially connects to the instructor's computer, their server that they're running, their Flask server. And yeah, so this is all just running on one person's machine, and that's I've considered different ways of maybe like distributive computing and such, but really they're all connecting. So really the only one computing is the instructor themselves. And yeah, and I mean, for when it comes to like speed itself, when initially with like the program, I was getting about like a minute to 2 minutes for hint generation because I just like hand optimized like how am I caching data? How am I like what data is being passed through the back end? Like there were some things that I think were slowing it down and I had too much context or I was trying to throw too much at it. So initially I went from like almost 2 minutes for a hint to generate to, I mean, 15 if you're going for the quicker version and 30 for more context. So yeah, I've optimized down from about 2 minutes.
So why not use the GPU?
You can use the GPU, and I mean, if you use the GPU, you get it like in, I mean, a handful of seconds. It's much faster.
Mhm.
And actually, a part of my program is I actually have the model. So with the prioritize speed and prioritize quality settings, you can also, there's an advanced settings section where you can specify how many cores do you want to use for specifically for this. And it also displays if you have a GPU, which hopefully you'll know if you have a GPU, but but essentially my program automatically by default will identify, it checks OS and it checks if you have a GPU. It enables it by default because most people, if you have a GPU, it's useful to do that. And yeah, you have a GPU, there's no downsides to it. It'll only speed up generation. And I mean, that's pretty much the preference. But yeah, I think kind of the big most interesting part of this is the ability to run it on the CPU, because I think a lot of people don't have dedicated graphics cards, especially like in the educational setting. Be able to run it on a CPU is pretty important.
Yeah.
Sorry, a quick question. Have you had a chance to work with the external GPU like a Coral Dev from Google or any other external GPU?
Like a hosted GPU, I think he's asking.
I've never had much experience. I haven't had any experience with like external hosted GPU. I had I mean, I was running inference if I was using my GPU, most of my tests were just using the CPU. The GPU I had was an RTX 4070 Super. And yeah, I was getting about a couple seconds, maybe like upwards of 5 to 6 seconds for generation for the whole hand. So, and it could be like, well, really, I think it went, most of the time it was like 2 to 3 seconds, but it could go up to like 6 seconds if it was.
And all of your test was on the plain data or was on the video or image or anything like that?
Like text data.
Yeah, it was just all text data.
Just a text. So I think for the video analytic and for video and image, probably the GPU would be very helpful.
Yeah, I think it's just kind of like at that text is at this reasonable with the CPU. But yeah, I think once you processing video data and more complex forms of data, like yeah, definitely GPU is CPU probably won't cut it, is my understanding.
Yeah. All right.
It sounds like a accessibility or affordability, maybe an equity kind of consideration. At Evergreen, we like to think about who has what hardware, who can run your tech product, who is it for?
Yeah, I mean, my initial inspiration is I just didn't want to ask for money.
Oh.
I wanted to do it on my own machine and like see what I could do before I like kind of it's kind of an easier thing to just push it off to an external API or do it like that. And I was like, what can I do on my machine right now? What can I like innovate? What is out there for me to use? So I guess kind of came down to utility and then there's added benefits, privacy and such, and it's accessible. And that was a primary thing for me is like education. Like I have not seen somebody with a GPU in education. So I'm assuming they're going to use a CPU, and that's my base assumption. And essentially I'm building a framework and a system that if you have a GPU, great, it makes it faster. If you want more context, you have a better system, you can add that. But from the baseline, I want it to be accessible on the CPU with the added benefits of it being completely local.
In your work, how often you update your model?
So I actually haven't been doing I have not fine-tuned anything with the model itself. So this is just out of the box 5.3 4K mini instruct. So specifically, And that was kind of an added benefit is our organization just doesn't have a lot of data yet. We've been kind of agile with our like data capture and like how we've been changing how we're logging and like what we're capturing and such. So a big part of that I thought of was like, okay, well, if we can prompt engineering, I think, can be a plus because it has a lot of flexibility, right? Like we don't need to fine tune right away. I just wanted to see what results we could get without fine tuning. And then as we collect more data, I already have the infrastructure here, so we can fine tune the model, update it, and it kind of builds up from this baseline of, what
So
can we do?
you're starting your model. So I think it's a good idea to, I don't know what would be the best
Mhm.
process to update them. How often is the best to update it? Besides the prompting engineering, I'm talking about just the updating the model. Because if you're updating the model, it's going to help you to have much better, more mature model, which is more customized to your application, for example. So
Mhm.
probably it's going to be more mature through the time. Just with the very small large language model, probably you're going to have after a while, you're going to have through the time you're going to have the same performance of the large language model.
Mhm. Yeah, I think I built kind of like the groundwork, and yeah, in the future, like fine tuning will definitely be a goal. Just with our data restrictions, yeah, right now it's pretty
Yeah.
much impossible without, or we get overfitting, and yeah, such. It was,
All right.
yeah,
Um, thank you so much. I have to drop it, but thank you so much for your presentation, and thank you, Paul, for inviting me.
Yeah, thank
yeah.
you,
Thank you for
Pedro.
attending.
And everyone here, thank you for making the time. We if you have to go, we appreciate you spending the evening with us. We have like 9 more minutes, and then I have to go also because it's getting dark outside. I don't want to bike in the dark. But the yeah, does anyone else have any questions? Anything come to mind?
Thank you, Taylor, for showing your work. Very impressive.
Thank you. No
Yeah.
problem.
Yeah, I'm actually have to head up. But looking forward to hear about your future project.
Yeah,
Thank you.
thank you, Sue. It was good having you. Thank you to Spulik. It looks like Dominic had to drop off as well. So yeah, it seems like a good time to bring it to an end. And yeah, we'll watch Taylor's future career with great interest. Please reach out to him on any of these contact infos. And yeah, have a good evening. We'll see you. We'll be back next Wednesday for a normal Code and Hang. Have a good night, everyone.
Yeah, I was thinking like maybe you can do I don't know, a little kind of like I saw you have this Smarty Plans project going on. Maybe in the end you want to do kind of like a project showcase.
Yeah, definitely.
Just yeah, but up to you. It looks very interesting.
Yeah, for sure. I wanted to time it right, like this week, because I know Taylor was back. He just sent me a great looking poster. And plus I happen to know that Pedram was interested in this, and we had a really great discussion. He revealed more than I thought. I thought like some of this was like proprietary, and he was well, we'll see. He might ask me to redact a lot later, but this is a great discussion, and we will present Smarty Plants more. Dominic, who was here, did a lot of great work. Gavin, another student, Cassidy, Taylor also did great work on Smarty Plants, and we just didn't have time to do all of it tonight. So maybe like could be a monthly talk. Like so yeah, look out for future Smarty Plants talk.
Yeah, for sure. All right, bye guys. Nice catching up.